All right, so we're diving deep into brain-computer interfaces today,
Okay.
or BCIs, as I guess the cool kids call them.
Right.
You sent over a whole bunch of articles and videos on this. Everything from, restoring lost function to
Hmm.
get this augmenting human capabilities.
Wow.
That's right.
Yeah.
We might be talking cyborgs, before this is all over.
Well, let's not get ahead of ourselves.
Okay.
But you're right.
Okay.
The field is moving incredibly fast.
Yeah.
What was once firmly in the realm of science fiction
Right.
is becoming reality.
Yeah. So for those of us who haven't been, reading up on this stuff,
Yeah.
what is a BCI? Paint me a picture.
So imagine a direct line of communication
Okay.
between your brain and a computer.
Uh-huh.
That's essentially what a BCI is.
Okay.
It uses electrodes to pick up the electrical signals
Okay.
produced by your neurons,
Mhm.
those tiny sparks of thought,
Right.
and translates them into commands that a machine can understand.
So, I think move my hand, and the
Right.
BCI tells the robotic arm to do it.
Exactly.
Wow.
And the amazing thing is we're seeing this happen in real time
Wow.
with people regaining abilities they thought were lost forever.
Okay, hold on, because that's what really grabbed my attention
Yeah.
in these articles.
Right.
People actually walking again, talking again. This
Mm.
isn't just theory anymore.
Absolutely not.
Yeah.
Take Gert Jan Oskum, for example.
Okay.
He was paralyzed in a cycling accident.
Oh, wow.
And now, thanks to a BCI system developed by NeuroRestore,
Okay.
he's walking.
What?
They've created a digital bridge
Wow.
between his brain and his spinal cord,
Uh-huh.
bypassing the injury.
Wait, so they implanted electrodes in both his brain and his spine.
Yes,
That's intense.
it is. And it requires a very specific type of BCI,
Okay.
one that's surgically implanted,
Mm-hmm.
what we call an invasive BCI.
Okay.
They offer the most precise signal,
Right.
but obviously come with more risks.
Got it.
Yeah.
So not something you would just get on a whim.
Right.
But for someone like Oscom,
Mhm.
the payoff is huge.
Exactly.
And it's not just restoring movement, right? There were stories about people regaining the ability to communicate.
Right, like Philip O'Keefe,
Yeah.
who has ALS.
Right.
He is using a device called the Stentrode,
Okay.
developed by Synchron,
Mm-hmm.
to communicate.
Okay.
The really cool thing about the Stentrode
Yeah.
is that it's implanted through blood vessels.
Ah.
No open brain surgery needed.
Okay, that's a game changer right there.
Yeah.
Less invasive, potentially safer.
Hmm.
It feels like we're on the verge of some major breakthroughs here.
We are.
Yeah.
O'Keefe can send emails,
Wow.
text messages, just stay connected with loved ones,
Right.
all because of this little device.
That's incredible.
It is incredible to see how BCIs are restoring not just physical function,
Great.
but that sense of connection and independence.
And there was that story about Anne,
So
the
bad.
woman with locked-in syndrome after a stroke. I mean,
Right.
imagine losing the ability to communicate
It's tough.
and then suddenly having that restored, even if it's through a computer.
Yeah.
Like the look on her face when she spoke through the BCI. Wow.
It really highlights the profound emotional impact of this technology.
Right.
It's not just about bits and bytes.
Right.
It's about restoring hope and giving people back a voice.
Okay, so we've got these amazing stories of people regaining a function,
Mm-hmm.
but then there's this whole other side of BCIs.
Right.
We need to talk about augmentation.
Yeah.
And when I think augmentation, I
Mhm.
think one name, Elon Musk.
Of course.
Right.
Neuralink.
Yeah.
Musk's company is certainly getting a lot of attention.
Yeah.
And for good reason.
Right.
Their goal is ambitious:
Yeah.
to develop advanced BCIs that can not only restore function,
Right.
but actually enhance human capabilities.
Yeah. Their whole merging human intelligence with AI thing.
Right.
It's both incredibly exciting and kind of terrifying, don't you think?
There's no doubt it raises some profound questions.
Yeah.
But first, let's look at what they've accomplished.
Okay.
They've already implanted their device, the N1,
Okay.
in 3 human patients under FDA approval,
Okay.
with plans to expand trials soon.
Wow.
And let's not forget those monkeys playing video games with their minds.
I know, right? Monkeys playing Pong with their brains.
Yeah.
It sounds like something straight out of a movie.
Yeah, it does.
But on a serious note,
Right.
what does this progress tell us?
Well,
Is Neuralink really on the path to creating superhumans?
I wouldn't say superhumans just yet,
Okay.
but their progress is undeniable.
Yeah.
They've developed a robotic surgeon,
Right.
R1,
Oh,
to handle the delicate process of implanting the N1.
okay.
This could significantly speed up and improve the safety of the procedure.
Okay. Robot brain surgery now. That's mind blowing.
It is.
Wow.
And while Neuralink is grabbing headlines, they're not the only ones making strides in this area.
Right.
There are other companies like Synchron
Mm-hmm.
taking a less invasive approach.
Okay.
And research is happening all over the world on BCIs for treating epilepsy, Parkinson's disease, chronic pain.
Right. So it's not just about restoring lost function or creating cyborgs.
Exactly.
There's this whole spectrum of potential applications from treating diseases to potentially enhancing our ability in ways we haven't even imagined yet.
Exactly.
And that's why this field is so captivating.
Yeah.
It forces us to think about the future of humanity, what it means to be human, and the incredible possibilities that lie ahead.
It really does.
And with those possibilities comes some serious ethical considerations, right?
Absolutely.
I mean, we're talking about technology that could potentially read our minds, control our actions, even change who we are.
Yeah, you're absolutely right.
Right.
And that's something we need to delve into. The ethical implications of BCIs are just as important as the scientific advancements.
Right.
If not more so.
So are we ready to open that can of worms?
Let's do it.
Because I think things are about to get really interesting.
It's a conversation we can't afford to ignore.
Okay. Ethics.
Yeah.
It feels like every time we talk about some mind-blowing new technology,
Right.
ethics is right there tapping us on the shoulder.
Absolutely.
But with BCIs, it's not just theoretical, right? We're talking about the potential to access people's thoughts, their memories. That's some serious stuff.
It is. Imagine a world where your innermost thoughts are no longer private.
Right.
Where a hacker could potentially access your memories.
Oh, wow.
Your fears, your desires.
Yeah.
It's a dystopian scenario, but it's one we need to consider.
Okay. Yeah, that's giving me some Black Mirror vibes.
Right.
And it's not just hackers, right?
Right.
What about corporations or governments using BCIs for surveillance or manipulation?
Precisely. If a device can read your brain signals,
Right.
it could theoretically be used to track your emotions, your reactions to advertisements, even your political leanings.
Right.
The potential for abuse is huge, and that's why we need robust regulations and safeguards in place.
So regulations are key, but what about the tech itself? How do we make sure these devices are secure?
Yeah.
I mean, we can barely keep hackers out of our email accounts,
Right.
let alone our brains.
You raise a good point.
Yeah.
Security is paramount.
Right.
We need to develop BCIs with multiple layers of encryption, authentication protocols, and fail-safes to prevent unauthorized access or manipulation.
Right.
It's not just about protecting individual privacy, but also national security.
Oh, I hadn't even thought about that angle.
Yeah.
Imagine someone hacking into a military leader's BCI during a conflict.
Yeah.
It's like something out of a sci-fi thriller.
It's not entirely far-fetched.
Right.
And that's why cybersecurity experts need to be involved in BCI development from day one.
Okay.
We need to anticipate potential threats and build systems that are resilient to attack.
Okay, so we've got privacy and security.
Yeah.
What other ethical landmines are we tiptoeing around?
Well, safety and long-term effects are a major concern.
Okay.
Implanting any device in the brain comes with risks.
Right.
Infection, inflammation,
Right.
potential damage to surrounding tissue.
Yeah.
And what happens if the technology becomes obsolete?
Right.
Do we just leave these implants in people's brains?
Right. Like, what if your Neuralink implant is the BCI equivalent of an iPhone 4 in a few years?
Exactly.
Do you need brain surgery to upgrade out?
Exactly.
Yeah.
We need to consider the lifespan of these devices.
Right.
The potential need for upgrades or removal,
Mm-hmm.
and the long-term health impacts.
Right.
We need rigorous testing and monitoring to ensure the benefits outweigh the risks.
And then there's the issue of animal testing. I read some reports about monkey deaths during Neuralink experiments.
Right.
It's hard to stomach, even if it's in the name of scientific progress.
I understand.
Yeah.
Animal welfare is crucial.
Right.
And any research involving animals needs to be conducted ethically,
Right.
minimizing harm and ensuring their well-being.
Mm-hmm.
Transparency is also key.
Okay.
Companies need to be open about their research methods and any adverse events that occur.
It feels like we're barely scratching the surface here.
It is.
It's almost like the ethics of BCIs is a whole other deep dive in itself.
It is, and it's a conversation we need to have on a societal level.
Right.
Scientists, ethicists,
Mm-hmm.
policymakers, and the public all need to be involved in shaping the future of this technology.
Because once this genie's out of the bottle, it's not going back in.
That's right.
Yeah.
We need to be proactive, not reactive.
Right.
establish clear guidelines, regulations, and ethical frameworks now before these technologies become so widespread that it's too late to course correct.
Okay, so we've talked about the potential downsides.
Yeah.
But I want to circle back to the positive side.
Okay.
For people with disabilities.
Right.
BCIs offer a level of hope that was unimaginable just a few years ago.
Absolutely.
Yeah.
The ability to walk again after paralysis.
Right.
To communicate after losing your voice.
No.
To control a prosthetic limb with your thoughts.
Right.
These are life-changing breakthroughs.
Yeah.
That have the potential to restore independence and improve quality of life for millions of people.
And it's not just about restoring lost function.
Right.
BCIs could help treat conditions like epilepsy, Parkinson's disease, chronic pain.
Yeah.
It's like opening up a whole new frontier in medicine.
Exactly.
Yeah.
And as the technology continues to advance,
right,
who knows what other applications we'll discover.
Yeah.
The potential is truly limitless.
But with great power comes great responsibility. Right?
You're right.
We can't just focus on the exciting possibilities without acknowledging the potential risks and ethical dilemmas.
Absolutely.
We're talking about technology that could fundamentally alter what it means to be human.
I couldn't agree more.
Yeah.
The decisions we make now will have far-reaching consequences.
Right.
We need to proceed with both caution and optimism.
Right.
Ensuring that these powerful technologies are used responsibly and for the benefit of all humanity.
Okay, so we've covered the ethical landscape.
We have.
Now I'm curious about how this stuff actually works.
Okay.
What's going on under the hood of these BCIs?
Yeah.
How are they reading our minds and translating our thoughts into actions?
That's a great question. And it's a fascinating journey into the world of neuroscience and engineering.
Okay.
Let's dive into the technical side of things and explore the nuts and bolts of how BCIs function.
Okay, so let's pop the hood on these BCIs.
Hi.
You mentioned electrodes before.
Yeah.
Those tiny sensors that pick up brain signals.
Right.
So like how many are we talking about? Are they like poking around in there reading individual thoughts?
Well, not quite reading individual thoughts yet.
Okay.
But we are getting closer to deciphering complex patterns of brain activity.
Okay.
The number of electrodes can vary widely, depending on the type of BCI and its purpose. Some systems use just a handful, while others, like Neuralink's N1, are packing in thousands.
Thousands?
Yeah.
That's a lot of hardware to cram into a brain.
It is.
What are these electrodes made of, and how do we know they're not going to, mess things up in there?
That's a critical point.
Yeah.
Biocompatibility is key.
Right.
These electrodes need to be made from materials that the body won't reject.
Okay.
Like certain types of silicon, platinum, or even flexible polymers that can move with the brain tissue.
Oh, wow.
Researchers are constantly working to improve the design of materials to minimize the risk of damage or inflammation.
Okay, so we've got these electrodes eavesdropping on our neurons. But how do they actually translate those tiny electrical signals into something meaningful, like a command to move a cursor or type a word?
That's where signal processing and decoding come in.
Okay.
It's not a simple one-to-one translation.
Right.
Imagine trying to understand a conversation in a crowded room with lots of background noise.
Yeah.
That's kind of what raw brain signals are like.
Okay.
The BCI needs to filter out the noise, amplify the relevant signals, and then decode those patterns into specific commands.
Like noise-canceling headphones for the brain.
Right.
But how does it actually decode those signals? Is it like a dictionary where each brainwave pattern corresponds to a specific action?
It's more complex than that.
Okay.
It involves sophisticated algorithms and machine learning.
Okay.
Think of voice recognition software. It has to be trained on vast amounts of data to learn how different voices and accents pronounce different words. Similarly, a BCI needs to be trained on tons of brain data to recognize the patterns associated with specific thoughts or intentions.
So it's basically learning to read your mind.
In a way, yes.
But it needs a lot of data and some serious processing power to do it.
It does.
Makes sense. You also mentioned bandwidth earlier.
Right.
How does that factor into the equation?
Bandwidth is crucial.
Okay.
It refers to the amount of data that can be transferred between the brain and the computer.
Okay.
The more electrodes you have, and the faster they can communicate, the higher the bandwidth.
Okay.
And higher bandwidth means more information.
Okay.
More complex actions, faster responses.
Okay.
It's like the difference between a dial-up connection
yeah.
and high-speed fiber optic internet.
The good old days of dial-up. Right. I remember downloading a single song taking like a whole afternoon.
Exactly.
So are we going to need some kind of brain fiber optic cable to achieve the full potential of BCIs?
Maybe not a physical cable.
Okay.
But the analogy holds.
Right.
We need to develop ways to transmit data more efficiently between the brain and external devices. It's not just about the hardware, though.
Okay.
We also need advances in software, algorithms, and processing power to handle all that information.
So it's this whole ecosystem of technologies that need to evolve together.
They do.
Neuroscience, engineering, computer science. It's mind-boggling how complex this all is.
It is, but it's also incredibly exciting.
Yeah.
We're literally pushing the boundaries of what's possible.
Right.
Merging biology and technology in ways that were once unimaginable.
It's like we're stepping into a whole new era.
Yeah.
A world where our minds can interact directly with machines.
It is.
It's both exhilarating and a little bit daunting, right?
Absolutely.
Yeah.
It's like standing on the edge of a vast uncharted territory.
Yeah.
We're not entirely sure what we'll find.
Yeah.
But we know it has the potential to change everything.
Right.
We've talked about the amazing breakthroughs, the potential risks.
Right. The ethical dilemmas and the incredible complexity of the technology itself.
Yeah.
What stands out to you most from our deep dive?
Honestly, it's the sheer potential of it all.
Yeah.
The idea that we could use BCIs to restore lost function, treat diseases, enhance our abilities, even explore new forms of communication and creativity.
Yeah.
It's mind-blowing.
It is.
But, as we've discussed, we need to be mindful of the risks and ethical considerations.
Oh, absolutely.
We're talking about technology that could fundamentally alter what it means to be human.
I couldn't agree more.
Yeah.
The decisions we make now will have far-reaching consequences.
Right.
We need to proceed thoughtfully, ensuring that this technology serves humanity rather than the other way around.
It's a responsibility we all share.
It is.
Well, to our listeners, we hope this deep dive has given you a glimpse into the incredible world of brain-computer interfaces.
I hope so.
It's a world full of potential both for good and for ill.
Keep learning, keep asking questions, and stay engaged in this conversation. The future is literally in our minds.